Hi guys, this video is going to help you with today's delta math using the factored form of polynomials, specifically with the x-intercepts and the graphs. So first we're going to talk about finding the roots when we have the factored form. So each factor needs to be analyzed. If the factor is linear, and so again linear is going to look like y equals mx plus b, then that factor is going to give us one root. With quadratic, we have to be careful. Quadratic could mean real or imaginary roots. So only real roots are x-intercepts. If it's got imaginary roots, that's not going to count because we can't see imaginary roots as x-intercepts. All right, so this first example, I have to go through every single factor and figure out how many roots it's going to give me. So first I notice I have an x out front. That is going to count as a factor because remember an x-intercept is some number that you plug in. Some number when you plug it in, it gives you 0. So obviously if you just see a random x hanging out, you could replace that x with 0, and then it becomes an x-intercept. So this has one x-intercept of x is equal to 0. All right, my next factor, that is linear. Even though it's being raised to the second power, that has to do with the multiplicity and what it's going to look like, but that's not going to tell us what the x-intercept is. If I take this factor and I set it equal to 0, I would add 6 to both sides, just solve that little equation, and I get x is equal to 6. All right, my next factor, that's also linear. So same thing, I'm going to set it equal to 0. Get x by itself, so I would have to minus 3 on both sides and then divide by 4. So there's another x-intercept. So far I have 3 x-intercepts. I have one at 0, one at positive 6, and one at negative 3 over 4. All right, my next factor this is quadratic, so I'm just going to have to be really careful when I go to solve this. Same thing, I'm going to set it equal to 0. I'm going to add 9 to both sides. All right, and this is just going to give me a real number because I can actually take the square root of 9. Imaginary roots are when you take the square root of a negative number. And so that's not going to happen in this case. If I take the square root, I'm going to get positive 3 and negative 3. So that's another thing that you have to consider. Let me go ahead and add this up here. That's going to give us 2 real. Whenever you take the square root, it's the positive and the negative. So you just have to make sure you remember that. The other thing that you could do is you might be able to recognize this as a difference of 2 perfect squares. So whenever you're subtracting and you see x squared and you see that that number is a perfect square, that factors into x plus 3 times x minus 3. So there's your 2 roots, a positive 3 and a negative 3. So if this was my question in Delta Math would say, how many x-intercepts are there? So we have 1, 2, 3, 4, 5, because we have positive 3 and negative 3. So this question has a total of 5 real x-intercepts. All right, so let's do the next one. All right, so be careful with constants that are out front. This constant is not x, right? It's just 5. So this, a constant number out front has no x-intercept associated with it because there's no x. X-intercepts have to come from factors that actually have an x. So that's not going to count. All right, so my next factor, this is quadratic, so I'm going to have to be careful. So I set it equal to 0. That's what I do every single time. Set your factor equal to 0. And now look, if I minus 4 from both sides, see how I'm about to take the square root of a negative? So this is about to be imaginary, which means it's not going to be an x-intercept. So I'm going to move on. All right, this is linear. Again, the 2 has to do with the multiplicity, but that's not going to matter when I figure out what the x-intercept is. So I set it equal to 0. I have to minus 6 on both sides. So 0 minus 6 is negative 6. All right, my next one. Again, that's linear. The 3 has to do with the multiplicity, but I'm not going to use that when I'm solving for the x-intercept. So I set it equal to 0. So I need to add 3 to both sides. So add 3. Divide by 2. All right, so if this question said how many x-intercepts, how many real roots? Here's 1, here's 2. This is 2 real x-intercepts, or 2 real roots. All right, so that's what you have to do. You set each factor equal to 0 and get x by itself. So just like do undo, just like we did with inverses, you just cancel out. You always cancel the addition or subtraction first. And so when you see that the factor has x squared inside the parentheses, be careful, because if you end up needing to take the square root of a negative number, that's imaginary, which means we're not counting it. All right, so next we're going to figure out what the factors are by looking at the graphs. So first I'm going to look at my x-intercepts. So I have an x-intercept here at negative 3, and I have another x-intercept here at positive 2. We do have to take into account what it looks like. We need to take into account the multiplicity. So again, this root, this is going to have a multiplicity of 2 because that looks quadratic where it's hitting the x-axis. And this root is going straight through. So this is going to have a multiplicity of 1. All right, all of the examples that you should have should be whole numbers. So it should be pretty easy to write the factor from it. So all you have to do when you're going to write the factor is do the opposite, because the factor is going to need to equal 0. So if it's negative 3 here, in order to equal 0, I need this to be plus 3. If this is a positive 2, in order for the factor to equal 0, if that's positive 2, I need this to be negative 2. So that's it. Whatever the x-intercept is, the factor should have the opposite sign. So keep in mind the multiplicities. Because this looks quadratic here, that factor should be raised to the second power to indicate the multiplicity of 2. This one was going straight through, so technically this won't have anything on there, but if it makes you feel better to put a 1, just these are our notes, then that's fine. All right, now what you do have to be careful for are those bumps that don't reach the x-axis that tell you you have imaginary roots. So do you see here is my parabola? And it was going towards the x-axis, but it didn't make it. Those are where you have imaginary roots. So I'm not going to be able to find the imaginary roots. All of your questions like this in Delta Math are multiple choice. So what you need to look for, if you have an imaginary root, is some factor that's x squared plus a number, because I would have to subtract that number and then take the square root, which would mean taking the square root of a negative. So if you see that your graph has an imaginary spot, then you need to pick an answer choice that has x squared plus a number. All right, so let's do the next one. So my x-intercepts, I have -1 and +2. I'm going to check out the multiplicities. So again, this has a multiplicity of 2 because that looks like a parabola. This one is going straight through. So this will just have a multiplicity of 1, which basically means it will have no exponent. And if you look, I do also have, here's a parabola that was going towards the x-axis and it didn't make it. It never made it to the x-axis. So that part of the graph tells me that I'm going to have something imaginary. So my imaginary root, I would be looking for an answer choice that had x squared plus a number. My -1 x-intercept needs a root that's x plus 1, right? They have to zero each other out. So if that's negative, then my factor needs to be positive. And then you could put a 1 there if it makes you feel better, but Delta Math is not going to have the 1 there. All right, so now my +2 needs a factor that's -2. And this does need to have an exponent of 2 there because of the multiplicity. All right, so I hope that helped you. Just keep in mind, trace the whole graph. When you see the graph going towards the x-axis, but it doesn't make it, that is going to give you an imaginary root. And so if it's imaginary, you're looking for x squared plus a number to be a factor. For the ones that go through the x-intercept, or they make that parabola shape on the x-axis, then whatever the x-intercept is, the factor should have the opposite sign. Your x-intercept and your factor need to zero each other out, so they should be opposite signs. All right, and again, going back up here, remember that you're going to set each factor equal to 0. But basically, you're looking for your linear factors are going to give you 1 root. Your quadratics are going to give you 2. But you just have to be careful because some of your quadratics could give you imaginary roots. And so we're not counting the ones that are imaginary. We only count the ones that are real. All right, and again, quadratic is going to end up giving you 2.